Okay? Okay. So now, we've got time to either do, so now we're down to the last thing, multi-step and two-body kinematics. So what we're probably going to do is do one of them, and I'll make like a video of the other one. Okay, I have a YouTube channel with a bunch of crap on it. So by the end of the semester, we'll have all kinds of 125 videos. So you'll be able to see all the ones I plan to do, because they're all important. Let's do the two-body. Okay, so multi-step and two-body. I think multi-step will be easier to handle. Two-body is the one that's kind of weird. And it's a way we go beyond plug and chug. Okay? Let's go beyond plug and chug. And it's actually easier than this one. I thought this little add-on would just be a fun little idea. I wasn't thinking about how difficult it actually is. Okay, so two-body, I actually have it written out here for you. Let's see, it's about 2 people in the mob or something. There we go. All right. So 2 people in the mob are marching towards each other, right? And the question is simply, where do they meet? Okay, this one requires some knowledge of football. I promise you, no exam or pledge problem will require knowledge of football. Okay, we don't do a lot of sports problems. I don't know. I was running out of ideas. Okay, so 2 mob members. That's like the band here. Y'all know that's the band, right? So they're marching towards each other. One is on each goal line of the football field. One carries Piccolo, so he goes really fast. One carries a sousaphone, so she goes really slow. Where do they meet? And you say, oh, this is easy. This is just D equals VT. All right, I just plug in D equals VT. It's plug and chug. It's not plug and chug. Because what do we know from the problem? We know, well, we know 1, and we know the second person, V2, T2. Well, we know the V's, but we don't know the T's and we don't know the D's. Right? So you can't really solve this by plug and chug. It's anytime you have a problem where 2 things meet, you got to think about what's going on. First of all, you didn't even draw it. Here we go. This is this. I'm going to call this 0 and 300 feet. All right, 100-yard football field, 3 feet per yard. We're going to call this the origin. You got to take your drawing and put it on an axis like that. And I think I've got the Piccolo player over here. Like, Mom, I don't want to play the Piccolo. Here it is. Yeah, so Piccolo's here, right, like this. And, boop, and then sousaphone is right here. All right, and the tongue, whatever. Okay. Okay, so the Piccolo is going 5 meters per second. We haven't done vectors yet, but I'm just going to draw an arrow just to make you feel good, and 1 meter per second. So we're going to figure out what we're going to do, right? When and where do they meet? So the key word when you're reading a problem like this is, what is the most important word here? Meet. What does meet mean? They meet. Meet is the key. And it tells you that at some time x1 equals x2. They're in the same place. If 2 things meet, they're in the same place at a specific time. I like to put a star on it. Right? There's some time. Time is not a variable here. There's a time when this is true. That's basically what that word meet is telling you. So almost all two-body problems are about 2 things meeting or 2 things passing each other or something. And that time that they meet or that they pass is the magic time. Okay? So what you want to do is sort of write the equation for each of these 2 people. You'd say, okay, we'll call this one 1, and we'll call this one 2. You'd say x1 equals v1 times t. Right? Seems right. But what about this one? x2 equals v2 times t. Well, they're never going to meet. One's going faster than the other. But I didn't do that right, did I? They're on this coordinate system. This one's going positive. This one's going negative. And this one starts at 300. Right? We have to have x final equals x initial minus v2t. If v2 is the magnitude of the velocity. It's 1 meter per second. We'll put the negative sign in like that. I forget which way I did it. Yeah, we'll put in the negative sign. And just say v2 is the number. It's not the negative. So that's the thing there. And then you say, okay, I need to know, do I want to solve for when they meet, or what do I want to do? Is I'll look at this and say, well, why don't I just set x1 equal to x2 and find t? Find the magic time. Right? At some time t, x1 equals x2. So basically, then you say x1 v1t equals 300 minus v2t, and it's t star, because it's the magic time. Okay? And then you can solve for t star. You just found them because these are all numbers that you know, right? So this is 5t equals 300 minus t, right? So 6t equals 300. So they meet after how long? They're dying to meet each other 50 seconds. That's when they met, 50 seconds. Okay. So two-body problems you got to think about when they're getting together. And then where are they? Well, you just plug it in. All right, so x1, where x1 is 1 times 50. He's at 50 feet. x2 better be in the same place. 300 minus 6 minus 5 times 50, 300 minus 250, 50 feet. They're in the same place, thank God, 50 feet. Which one's 50 what? Oh, switch around. They're both the same answer. Did I say them backwards? Oh, they're 250. I'm sorry. I'll flip the negative sign around. That's what I meant to say. There we go. Fixed. But you get the idea. When you plug in the t, you'll get them at the same place. Yeah, I'll switch to V1 and V2. Okay, so that's how you do a two-body problem. What I didn't tell you is how to do multi-step. That basically means something was accelerated by my hand and then free. So acceleration change. You got to do it in stages. I'll do like a video of that or talk about it next week or something. Okay.
Oh, will that be on Canvas?
It's on Canvas too, yeah. So labs, I believe, start next week. Definitely not this week.